Welcome. This is our first podcast from the Vatican Observatory Foundation. With us, I have Brother Guy Consimano and Larry Lebofsky. I'm going to have you two introduce yourself, Brother Guy.
I'm actually also Dr. Brother Guy, and I'm the director of the Vatican Observatory. I'm a planetary scientist. I did my undergraduate work at MIT, which is where I first met Larry, because he was the TA as a grad student of a course I was taking as an undergraduate on how to observe and how to use a telescope. My field of interest is meteorites and their connections to asteroids and the evolution of small solar system bodies.
Okay, Larry.
My name is Larrylebowski, also doctor, though I tend to avoid using the term. I just like Larry or Dr. Larry. I was an undergrad at Caltech and then a graduate student at MIT, which is where I met Guy. Then went to the University of Arizona and spent 30 years there, doing mostly small bodies in the solar system, Saturn's rings, moons around other planets, studying comets and other things like that, and mostly involved with doing water on other objects. So planets, moons, asteroids.
Well, today's topic, we're going to be talking about what space movies and TV, what did they get right and what have they gotten wrong? Let's start with that number one. What TV shows or films get the space experience right?
Just as a little background to see why we have expertise in this, I was very active in the MIT Science Fiction Society back when I was there, and I've been a big fan ever since. And Larry, you've taught about this stuff, right?
I've taught about this stuff. Most of what I've taught is tended to be using old science fiction stories. So just because of the students, of getting them to see what science was in old science fiction books primarily, and movies too, and how technology has changed from the 50s and the 60s up until the present time.
And the two of us have a regular research program where we meet over at Larry's house with Larry's wife, Nancy, to watch trashy science fiction movies every Sunday afternoon, or at least we did until COVID hit. And so we've got a pretty good backlog of bad science fiction. But you asked for good science fiction, and that's somehow trickier to come up with. Let me give you an example of something that they got right, which you would think would be totally outlandish. And that was, in a sense, the asteroid in the second Star Wars movie, The Empire Strikes Back, because it showed asteroids with giant cracks big enough to hide the Millennium Falcon. And one of the things that our research has shown is that asteroids are piles of rubble. We don't know the scale of the gaps in them, except from the asteroids we've actually seen. We've never seen cracks big enough for the Millennium Falcon, but then we haven't seen monsters living inside them either. Yet the idea that asteroids are not big solid rocks, but rather very jagged, very loose, and possibly with a lot of voids, that certainly is correct.
The one of the issues that one gets to with a lot of the movies that have asteroids in them is that if you're on an asteroid or flying through an asteroid field, you'd have asteroids all over the place and you'd be sitting there trying to avoid them. And that's so far from true. Basically, if you were on an asteroid looking at another asteroid, it would almost look like the sky you see from the Earth. They're in fact really far apart.
When we do fly through the asteroid belt, we have to go out of our way and work hard to be able to find an asteroid that we can go past. It's not trivial to do.
Space is big.
And asteroids are small.
So what TV programs or movies have gotten things wrong? I'll let you guys go, then I have a couple.
All right. I'll actually throw in one other that I think got it right.
Oh, okay.
In a funny way. And it's not about science, it's about engineering. One of the films that I absolutely loved and was surprised to love was the first Iron Man movie. And the bit of engineering that just delighted me, besides the fact that Tony Stark is an MIT grad, of course, is that it showed him trying to make the Iron Man suit work and going through a series of failures, because each piece might work, but getting all the pieces to work together will lead to sometimes disastrous and sometimes humorous failures. But the joy that came with doing that, I found to be delightful. Now, that's engineering. I'll give an example of an astronomy movie that was frustrating because it could have been right and wasn't. and that was Deep Impact. Now, you remember that Deep Impact and Armageddon came out at the same time with roughly the same theme of an asteroid coming to, hit the Earth. I'm not going to talk about Armageddon because it only had one problem, namely everything.
There must have been something right, but I have a hard time thinking about what that would have been. But yes.
Asteroids were jagged.
Yeah, maybe. But Deep Impact had so many things that they could have done right and they got wrong. For instance, the astronomer observing the asteroid is sitting in the same room as the telescope with the lights on. Well, you could argue that's all you have to do it to make, but people have not sat in the room with the telescope doing observing for 30 years. You observe from a room that's thermally and light isolated from where the telescope is. You're staring at a computer screen.
Also keeps you warmer. It is really cold in the dome.
That's true. I remember as a student that we had these one-piece zip-up suits to try to keep ourselves warm back in the days when you actually were with the telescope. And you were standing still and you wound up doing stupid things like stepping off the platform, forgetting that you were 10 feet above the ground, hitting the wrong knob without realizing you had done it and invalidating the next hour's worth of work.
Or trying to push buttons with thermal gloves on.
Yes, that was one frustrating. Another was that, he discovered this asteroid and he writes a letter to Carolyn Shoemaker. When you see her name on which at least I got Carolyn Shoemaker's name right. But you wouldn't, if you discovered something like that, you wouldn't write it in a letter and put it through the U.S. Postal Service. I'm sorry.
Well, back in the old days, you might do that, but not in.
Not even.
Not now. Not now.
Not by the time they made the movie, even.
This is true.
So one of the things that science fiction movies gets wrong quite frequently that drives me crazy is orbital mechanics. There's a series called The Expanse, which is very popular, both book and series. And the series, the way it shows orbital mechanics is dead on. Flip and burn, RCS, all that stuff. I play a game called Kerbal Space Program, and it teaches orbital mechanics. And I was watching the movie 2010 shortly after I was playing that. Now, the U.S. ship encounters Jupiter, and they send a probe down to the moon. Then, after all that happens, then they do this huge aerobraking, and I'm like, wait. If they send that probe down to begin with, they're still going interplanetary speeds. They have to do the aerobraking first to get into the system. So I was just like, wait, that's not right. And I've seen movie after movie get that completely wrong. And most people won't know that that's completely wrong. Now, The Expanse, again, they get it very right.
And I can't remember which of the Asteroid Disasteroid movies, we like to call them, it was where they had the astronauts who were on their way to Mars go to behind Vesta the asteroid in order to watch an impact occur. And I can't remember if that was that Deep Impact or was that something else?
That was something else. Deep Impact. They didn't have anybody in space.
That's true. Yeah. Okay. But I don't remember. It might have been Meteoroid or Meteorite, one of those movies where, okay, you're on your way to Mars. You're not going to be able to easily and quickly move yourself from an orbit that's taking you to Mars to an orbit that's going to take you into the asteroid belt. And then hide behind the asteroid so you can see where the impact occurs in the asteroid belt. And then, of course, they get killed because of the fact that the debris flies all over the place and hits them. But yes, it's the orbital mechanics and how things move in space are usually not even close to being right.
I remember hearing for the movie 2001, the docking sequence of the space plane with the Taurus space station. The way it moved was actually very accurate orbital mechanics wise. And again, a couple people in the audience are going to notice that's right, but the rest of the audience there just aren't going to know that.
One movie that really went out of its way to get a lot of things right was Apollo 13. One of the major mistakes they made in Apollo 13 is that his Corvette was actually blue, not red. It was at that level. But that was one that I thought did an excellent job of showing both how things were done and the attitudes of the people involved in doing the things.
Yeah, that was a good movie.
My
Yeah.
wife has shown that to her students for the past several years, and every year she gets, I didn't know this was happening. Like, that's why I'm showing it to you.
The other series that goes along with that is, of course, From the Earth to the Moon, the HBO series on Apollo program. And those are films that you can show classes. That the one especially on the design of the lunar module, the lunar lander, is great fun. But also the one on Apollo 15 talking about how the astronauts were trained. I mean, Larry and I can watch that movie and identify who the characters are based on because we knew the people involved. It was a small field.
Okay, so one other question I have here is how can sci fi shape or prepare humanity for either traveling to other planets or interstellar life?
I mean, I grew up in the 50s. I'm the older person here. So I grew up with Rocky Jones, Space Ranger, and Flash Gordon, and all those. And those were exciting things. Did they get the science right? Not even close. But they were exciting. And they were way ahead of the science at the time. I think it's harder these days because a lot of times the science is almost as good as the science fiction you could do without getting into science fantasy, like faster than light travel and other things like that. So I can't say what is happening now in the field. To me, I think you can get almost as much excitement from the real thing as you can from science fiction as to what's going on.
Especially if you're talking about near future stuff. I remember watching a Flash Gordon where they're running through a lab, and I think Flash holds up a beaker and hands it to what's her name, and goes, "Do you feel that? Yeah, right. Do you feel that tingling sensation? That's radioactivity."
Yes.
Yikes!
And yet, for the 1930s, it introduced the idea of radioactivity to an audience. So it's not necessarily the case that you've got to get the science right if you can even just get the language across.
I mean, the one thing that was considered at the time, the one thing that will never exist were their ray guns, which are lasers. Right. So in the 30s, that's never going to happen. How could you possibly have something that would shoot out a high energy beam? And the answer is they exist. So that was an interesting concept back then that turned out to be true.
And not only that, but in some cases it becomes self-fulfilling. The first cell phones that looked like that would flip open like the communicators in Star Trek. And that was done deliberately because the guys, who were designing these things had watched Star Trek. Or I think many people know what a taser is, and you probably know what the acronym TASER actually stands for. Thomas A. Swift Electric Rifle.
Are you kidding me?
Serious, yes.
Yeah, because the guy who invented it thought this was something out of Tom Swift stories.
Well, that's funny you should mention that because shortly after the Chelyabinsk asteroid incident in 2013, there was a thing hosted by the White House where they had a whole bunch of planetary scientists and asteroid specialists talking about that event. And one of the questions they asked them was somehow it got around to Star Trek inspiring every single one of these people to go on and be an engineer or a scientist.
I'll give an example of that. I was at MIT. I arrived there in 71 as a sophomore. I transferred in. Stayed for a master's there, so I was there through 75. In 75, the class of 78 arrived. The class of 74 that I was part of was 9-to-1 male to female. The class of 78, 4 years later, was 4-to-1 male to female. And part of it was MIT went out of the way to recruit women to come. But they discovered that the one thing that the women who decided to come to MIT had in common was they were Star Trek fans. They were in high school or middle school when Star Trek was on TV, and they saw women doing these sorts of things and said, hey, I can do that too.
I think Star Trek was essentially the first science fiction where women had almost equal roles to the men. It sure wasn't in the movies of the 50s.
Heaven forbid.
It's funny. My wife, my in-laws upstairs were watching a Western, and I've seen audiobooks of some of the older science fiction. When was the last time the word darling was used in a science fiction movie or a Western?
Not ironically, you mean.
Yeah.
Yikes.
Some things have changed for the better, yes.
One of the questions I have here is, how does sci-fi drive technological progress? From my personal standpoint, kind of like that. I'm a huge computer gamer, and I have seen graphics cards go from practically nothing to $1,000 monsters recently, and that's just one of the things. So gaming, and a lot of gaming is science fiction gaming. That's driving computer hardware.
One of the things that I was shocked a few years ago at the Vatican Observatory, we have a summer school every 2 years where we bring in kids from, around the world, 25 really bright kids, and they do 4 weeks of intensive work. Well, the topic one year was globular clusters, collections of 500,000 stars, all in orbit around a common center of mass. And these can now be modeled on a small computer because the NVIDIA cards that were designed for gaming are ideal for doing the intensive number crunching that you need to do to model the orbits of 500,000 stars in a globular cluster.
Yes, when I was growing up or when I was at Caltech, it was basically if you could do 3 or 4 objects, you were doing well. It definitely changed.
The technology has completely changed the things that we ask ourselves and the way we go about trying to find the answers. There was the Lunar and Planetary Lab here at the University of Arizona had a seminar over the summer, and one of the students gave a talk on handling massive amounts of data, big data, and how we process it and how we use intelligent machines. When I was a student, we didn't have massive amounts of data. We barely had any data. And the trick was, how do you do science when you actually don't know anything? I mean, I wrote computer models for the moons of Jupiter, where the only thing we knew about the moons of Jupiter was their size. We had a rough guess of their mass and maybe their albedos, and that was it.
And when I was first getting into my study of asteroids, we didn't even know that.
So part of the joy of science fiction for me was that it gave me a way of imagining and dreaming about these places and thinking, what questions can we ask? What ways can we even think about it? Let me tell you a story that was really important to me, how science fiction changed my science. I was doing these models of the moons of Jupiter, and one of them, Io, was suddenly discovered to have these strange volcanoes. Nobody knew quite what they were, except that they were bright orange. And the guy in charge of the imaging team, the Voyager team, was going around saying it's some kind of primitive juice coming out of these volcanoes. I had read a science fiction novel by Hal Clement called Ice World, where the ice involved was actually sulfur. And he had aliens who lived on a planet that breathed sulfur. Sulfur is, just below oxygen in the periodic table. It ought to have similar chemical properties. And they were astonished at Earth, where the sulfur was frozen. And I go, sulfur is a gas at not too high a temperature. I have my one and only paper in science is sulfur volcanoes on Io. And in the acknowledgments, I give credit to Hal Clement and his novel Ice World, because that's where I got the idea.
Alrighty, so thank you very much, Brother Guy, Larry Lebofsky. We will be back with another podcast. Hope you join us.
Thank you very much.
It's been fun.